the notes for the 2.7 section of APB. We're going to look at motion graphs and what they mean. And the three motion graphs that you have to know are the following. We have the first graph is position versus time, the second graph is velocity versus time, and the third graph is acceleration versus time. And these are the three graphs that we have to know, and you have to know them in this order. And we're going to do some examples of situations that we have to know how to graph the motion. So we're going to have a situation where we have somebody standing at the 2-meter point. You'll see a picture up here that this person is standing at the 2-meter point, and so that means their velocity is 0. So I can just easily write down velocity equals 0 here. We also know their acceleration is 0. They're not changing their speed. The velocity is 0 because we know they're not moving. And their position stays right at 2 meters. So we know this line is straight across horizontal. So because after 1 second, the person's still at the 2-meter point. After 2 seconds, still at the 2-meter point. And 3 seconds, still at the 2-meter point. So we have these three graphs that show this person's position. Now our next situation is when this person moves at a constant velocity of positive 3 meters per second. And I want to draw the three graphs for that. Well, we know the graph of positive 3 meters per second will, this middle graph, if we do the velocity versus time graph, we know that the velocity stays 3 meters per second the whole time. We also know that since that velocity is not changing, acceleration is 0. And we know that this next graph, after 1 second, they'll be going 3 meters per second. They'll be going 3 meters. After 2 seconds, they'll be going 6 meters. After 3 seconds, they'll be going 9 meters. So we have this line showing what their motion is. So the interesting thing here that we're going to start learning about these motion graphs is that the slope of this position or this displacement versus time graph actually gives us our velocity. So if you take the slope of this line right here that we've just drawn, this position versus time graph, you'll see the slope of that line is 3. So the slope of a position versus time graph is 3 meters per second. And you'll also notice that the slope of a velocity versus time graph will give you acceleration. If you look here, this slope here is 3 meters per second. And if you come over here, this slope equals 0 meters per second squared. That is the acceleration. So the slope of a displacement versus time graph, that gives us the velocity. And the slope of the velocity versus time graph, that gives us our acceleration. So when you're going from one graph to the other, when you're going from a displacement versus time graph to a velocity versus time graph, you're finding slope. And then if you have a velocity versus time graph and you're going into acceleration, again, you find the slope. So let's look at another situation where the person is, let's have the person moving backwards in the negative direction. We have a person starting at the 10-meter position and moving at negative 2 meters per second. So we want to go ahead and graph that. And we know the acceleration is 0 again, so let's go ahead and put that down here, that's 0. And the velocity we know is negative 2 meters per second. So actually I should have had my graph a little bit better set up here, but we'll fix that right now. So since we're moving at negative 2 meters per second, it's going to be a straight line across like this. And now we know that our starting point is 10, so we have to be way up here at time equals 0. We know that we're moving at negative 2 meters per second. So after 1 second, I'm going 8 meters per second. After 2 seconds, not 8 meters per second, I'm at the 8-meter position. After 2 seconds, I'm at the 6-meter position. After 3 seconds, I'm at the 4-meter position. So this is my motion right there. Now, if I were to continue it on, we can see where the person would hit the x-axis, what time that would happen. But the important thing to realize is the slope of this line right here equals negative 2 meters per second. The slope of that line gives me velocity. So we see that the velocity is negative 2 meters per second as well. We come down here, and we know that the slope of this line is 0, so that means the acceleration is 0 meters per second squared. So the slope of a velocity versus time graph gives me acceleration. Let's look at a third example. In this third example, we have a situation where the person starts from rest at 0 meters per second, at position 0, and they accelerate at a positive 1 meter per second squared. That means they're getting faster and faster and faster. So we're going to go ahead and draw that acceleration graph of 1 meter per second squared straight across, because you always have an acceleration of 1 meter per second squared. And we know we start off at 0 meters per second, but after 1 second, we are going 1 meter per second. After 2 seconds, we're going 2 meters per second. After 3 seconds, we're going 3 meters per second. So we have this nice line there. And over at the displacement versus time graph, I have to decide how to get the displacement versus time graph. Now, I could use the equations that we did before, but I'm going to do it by using the graph. And actually, it really is one and the same thing. There's a new rule we're going to learn here, that the area under a velocity versus time graph will give me displacement. And what's interesting also is that the area under an acceleration versus time graph will give me velocity. So if you look at, let's look at the acceleration versus time graph. If I look at this red line across and I look at the area underneath that line right here, this area, after 1 second, I see that that area is 1 times 1. And if I come over here, I see that I'm at 1 meter per second. Now let's find the area at 2. So I want this whole area, this whole thing. That whole area is 2. So that's, if I come up here, 2 meters per second. And after 3 seconds, this whole area is 3. So over here, I can see my velocity is at 3 meters per second. So the area under a velocity, or I'm sorry, the area under an acceleration versus time graph equals velocity. And now, if I use that same concept, I can say the area under a velocity versus time graph gives me the displacement. So let's look at this area here. After 1 second, I'm going to find the area of this triangle right here. If I do 1/2 base times height, that means after 1 second I have gone half a meter. So I'm going to be, I start off at 0, 0, so to 1 second, I'm at half a meter. Now let's do that for 2 seconds. Let's find the area under the line. After 2 seconds, we'll just find this area. We'll do 1/2 base times height. That gives me an area of 2. And so that triangle has an area of 2. So at 2 seconds, I have a displacement of 2. And now let's go ahead of 2 meters. And let's go ahead and now at 3 seconds, let's find what the area under this graph is. And that's 4.5. So at 3 seconds, I've gone 4.5 meters, which is up here. And you'll see this parabolic curve form. And so what we have here is a parabolic shape, which matches the delta x equals VOT plus 1/2 AT squared equation. So the rule here is that the area under a velocity versus time graph equals the displacement. So if you were to draw out these 3 graphs, what it basically comes down to is that if you have a position versus time graph and you want to solve for velocities, in other words, you go in this direction, you want to solve for velocities, you look at the slope of the position versus time graph to give you velocities. If you have a velocity versus time graph and you want to solve for accelerations, you find the slope of this graph. And actually, I'll draw a graph here, just a graph like this. We have a graph like this. Another graph like that. And so that's how that works. And if you have an acceleration versus time graph and you want to solve for velocities, you go back the other way. And that gives you that graph if you find the area under your acceleration versus time graph. And if you have a velocity versus time graph and you want to solve for displacements, you go ahead and solve for the area. And that will give you your displacement. So it's the 3 graphs are numbered in this order for this reason. So you can go from left to right or right to left in terms of finding slopes or areas.